In this example, we'll discuss graphing quadratic equations. To graph them, we're going to start by selecting a set of x values, plugging them into the equation, and finding the corresponding y values. So I've already selected a set of x values. It's important to choose x values that are both negative and positive. And you can see I've just chosen ones on both sides of 0 here. So let's go ahead and plug these in for y. So I'm going to do my work over here. So y is equal to 3 times the x value of negative 3 squared minus 8. We'll see what that's equal to for this y value here. So it's going to be quick to just use the calculator to do all of this. 3 times negative 3 minus 8. Was it minus or plus? Yeah, minus 8. Oh, I forgot to square it. There we go, then minus 8. Alright. Okay, so the first value is 19. So it's going to be a bit high for my chart. So I've got 19 there. Then the next value is going to be, I'm going to hit second enter just to bring that line up, and I only need to edit one value. So let's just change that to a negative 2. So the next value is 4. Same thing again, second enter to bring that line up. The equation stays the same, but now we're plugging in a negative 1. So that's negative 5. Okay, the equation stays the same, but now we're plugging in 0. I don't really need my calculator to plug in 0, because I know 3 times 0 is 0, minus 8 is negative 8. Let's plug in 1. So it's usually faster just to hit second enter and go back to plug that number in. So this is negative 5. Try 2. Oops, I hit the wrong button. Second, then enter. So this one's going to have 2. This one's 4. And the last one we're plugging in is 3. Okay, and that's 19. Alright, so let's graph these ordered pairs. Negative 3, 19. We'll say is way up here somewhere. We'll approximate that. Negative 2, 4, right here. Negative 1, negative 5. 0, negative 8. 1, negative 5. 2, 4. And 3, 19 again. Approximate that right here. Okay, so let's connect these, and the shape of this graph is going to be a curve that's going to come down in here and then come back up. And again, it's kind of hard to draw this with my mouse right here, but you can see the general shape of this curve is sort of a U shape, a very steep and narrow U shape in this particular case. So a couple of things to talk about this graph. First of all, the sketch of a quadratic equation, this shape right here is called a parabola. Okay, so anytime I have a graph that's going to be this U shape, it's a parabola. It could also be a U shape in the other direction. So those are just two different sketches of parabolas. If a parabola opens upward, so opens upward is this case, then it has a lowest point or minimum, and if a parabola opens downward, okay, so opens downward is this case, then it has some highest point or maximum. Regardless of whether it's a minimum or a maximum, that highest or lowest point on the parabola is called the vertex. Okay, so in general, if you want to talk about the turnaround place of the parabola without classifying it as a max or a minimum, you could use the word vertex. Okay, let's go back up to this parabola right here. The vertex, the turnaround place, the vertex of this parabola was the ordered pair 0, negative 8. Oops. I almost drew an infinity for some reason, but 0, negative 8. Now you can also notice, once you found the vertex, the ordered pairs were symmetric around it. See how we have pairs of y values here symmetric around the vertex. It's not a coincidence. Parabolas are always going to be symmetric around their axis of symmetry, and their axis of symmetry is the vertical line stretching above and below the vertex. So the same thing going on both sides, a mirror image. So those are a few of the properties of a parabola, or the graph of any quadratic function. So a quadratic function, again, was something that had an x squared as an exponent. Any quadratic function is going to graph in the shape of a parabola.